One of the really useful things about triangles, and it's basically what all of trig is based on, is the idea that for any angle that you can draw and create a right triangle with it, there's a ratio that exists between these two sides. And no matter how big or small this triangle is, if that angle is the same, the ratio between those two sides will be the same. This means that if this is, let's say this is a 30-degree angle, the relationship between the opposite side and the hypotenuse will always be the same. This opposite side will always be equal to 1/2 of this side. So we come up with something like a ratio of this. And we can write any ratio as a fraction. So if we wanted to say the ratio of the opposite side to the hypotenuse, that ratio would be equal to 1/2. Basically, this is just a representation saying that the opposite side is always equal to half of the hypotenuse. And this is true anytime you have a 30-degree angle. So we could go through and we could memorize the relationship for every angle. Well, probably not, because there's an infinite number of angle possibilities, which means we'd have to remember an infinite number of ratios. That'd be pretty tough. So for a while, what they did was they just had these tables where whenever you wanted to know the ratio that existed for a certain angle, let's say I had a 70-degree angle. Well, the relationship is no longer 1 to 2 like it was for a 30-degree angle. Now that I have a 70-degree angle, there's a new relationship. This, the opposite side here is related to the hypotenuse in some way, but it's no longer a 1 to 2 ratio. So what you would do is you would go and look up in a table or a book, you would look for, okay, 70 degrees, what is the relationship between the opposite and the hypotenuse? And you would get some number. That number would tell you basically the same thing as what we just had here for the 1/2. It would give you some idea of how this number is related to this number. But instead of having to go look it up in books and to do all of that, your calculator has a button on there that incorporates a function. Now, the first one that I'm going to talk about, and just because we're using opposite and hypotenuse, is the sine function. So what the sine function does is it takes in some angle and it basically does the lookup of the tables for you. So you can think of it as doing that when you type it into your calculator. When you type in an angle and you give that into the sine function, what it gives you out is this relationship, this ratio. So basically we can say the sine of our angle, in this case 70 degrees, is equal to the relationship or the ratio of opposite over hypotenuse. Opposite over hypotenuse. So that means that if we know one of these sides, we can figure out what the other side is because it has to obey some ratio. So if we, let's say we knew that this side down here was so let's say that we knew that this side over here was equal to 10. Okay, so that's the opposite side. And let's say I wanted to know how long the hypotenuse was. Well, I know that the ratio of the opposite to the hypotenuse has to be equal to 10 over x. And that ratio has to be equal to the sine of 70 degrees. So 10 over x is equal to sine of 70. They're the same. Whatever the number is that goes on the bottom, it has to make this fraction equal to whatever we get when we put sine of 70 into our calculator. So let's do that really quick. When we put this into our calculator, we get that the sine of 70 degrees is equal to 0.939696. And you may have more numbers out here, even more exact. And that's because there really is an exact value for this function, but whenever we are using our calculator and doing calculations like this, sometimes we have to decide where to stop writing down the numbers. So we've got that 0.9396926 is equal to 10 over x. So before I start doing the algebra of this, I want to talk about what this actually means, what we're trying to find when we're looking for x. Basically, what we're doing is we are looking for the number that whenever we take 10 divided by that number, it gives us 0.9396926. Okay? So I'm going to show you some shortcuts later that will sort of hide this step, but I don't want you to forget that that's actually what you're doing, is looking for the number that when you divide 10 by this number, you get your other value over here. We're trying to make both sides of this the same. So we know that the ratio of our sides is going to be this this ratio here. So this has to be the same. So the algebra here is that we want to get x by itself. So in order to isolate your variable, the first thing that we need to do is we need to get it out of the denominator. So we're going to multiply by x on both sides. Remember that as long as you do something to both sides of the equation, as long as you do the same thing, then algebraically it's okay. That's what this equal sign says, is that anything we do to this side, we also have to do to this side. So now we've got x times 0.9396926 is equal to 10. Remember that anytime we have something in the numerator and the denominator, we can cancel it out. So I can cross out those two. All right, so now I have one more step. My goal is to isolate x, because that's the number that or the variable that I'm interested in. I want to know what x equals. Anytime you are trying to isolate a variable, you want to figure out what operation is going on and do the opposite. In this case, we are multiplying by 0.9396926. The opposite of multiplying by that would be to divide by that number. So I'm going to divide both of these by 0.9396926. Do the same thing over here. And when we put that into our calculator, again, over here we have something on the same on the top and the bottom, so these cross out. We are going to have that x is equal to 10.64. And I just rounded it to 2 decimal places. Rounded it to 2 decimal places there. So 10.64. And that tells us that our hypotenuse of our original triangle is 10.64. So you could always plug this back in to try to figure out if that ratio still is, if it's true backwards. I mean, it has to be, right? That's how we found it. But sometimes we plug numbers in wrong and maybe it doesn't come out right. In this case, to check our answer back, we want to see if 10 divided by 10.64 is the same as this sign value over here. So let's see what we get. 10 divided by 10.64 is going to give us 0.939, and then I get some numbers after that. But remember, I rounded that final answer. So 0.939. So the ratio is still the same. Yeah, I took the other one out to like 8 decimal places, but it doesn't really matter. We're going to end up with basically the same answer. So 0.939.